By the end of this video, you'll have your very first 2D game in Godot 4. No confusion, no updated methods, just a clear hands-on guide. We'll be following the official Godot docs, so all credits go to the Godot community and contributors. This video is just a follow-along for visual learners who want to see everything in action, from setting up the project to using the latest up-to-date techniques in Godot, all the way to pushing the final project to GitHub. Here's what we'll build together: a player scene with smooth movement, a basic enemy setup, the main game loop and scenes, a simple HUD, a clean wrap-up to finish the game and version control it. Everything you see here is up to date with Godot 4.4. Let's get started. Here's a quick demo of the game. Before we start, let's try to download Godot 4. In the description, I provided the document if ever you need it. So you can just click on this one. And for this video, we're going to be using this first engine, this one. But if ever you want to use C#.net, you can use this one, but we'll be using JavaScript for this video. If you have Godot ready, let's start with the first chapter. If you're done downloading Godot, let's check out the first 2D game docs. Click on this one. This is a step-by-step tutorial series where you learn to make your first 2D game. This is the game that we'll be making. This project is Introduction to Game Engine Godot. These are the files that we'll be learning. And they recommend starting with 2D since it's much more simpler than starting with 3D. So it gives you the right foundation right away. And here you can download all the assets. I'll just click on this. And these are all the chapters or contents. If you had Godot installed, let's open it up. Let's start off by setting up the project. This is the first part. Here we'll set up and organize it, and we'll create a new project here. And we'll name it 2D game. I want you to click on browse and search for the folder where you want to put it. I'll place it right here. Select current folder. I'll click on create. If you've installed the assets in the page, you can just click on extract here. Click on this, and I want you to highlight this one and Control C. Then I want you to locate the folder, or maybe just drag and drop it right here. There we have it. We have all the assets imported. If you want to double check, you can click on the folder location. I placed it right here. And these are all the arts and fonts. The game that we'll be making is designed in portrait mode, so we need to adjust the size of the game window. You can click on project settings. In the left column, there should be a display section. Click on window. We'll look for the viewport width and viewport height. Since the width and height will now be portrait, we'll change it to 480 to 720. Also, under the stretch, we'll change the mode to canvas items, and the aspect to keep, it's already keep. I'll just close it. If you're wondering why we set up the stretch mode to canvas items, it makes all the objects, sprites, etc. inside the game stretch and shrink based on the screen size and not the whole game window itself. So if you're familiar with SVG, it's basically like that, and we're setting all the assets to be dynamic and the aspect to make sure that it doesn't stretch weird or squish like in Photoshop. To organize the project, we'll be making like 3D dependent scenes which will combine into game's main scene. They recommend here that in a larger project, it might be useful to create folders to hold the various scenes and their scripts. But for relatively small game, you can save your scene and script in the project folder. But I highly recommend that you practice it right away. So to do it, you'll just make a new folder and name this one to scripts. and another new folder for the scenes. They were making this folder because, just like they say, if the game gets larger, it will have a lot of scenes and a lot of scripts. These folders will let us able to organize the project and identify the scripts and the scenes that we need right away. Congratulations on finishing chapter 1. This is setting up the project. Let's proceed to the next section, creating the player scene. The first scene will be the player object. One of the benefits of creating a separate player scene is that we can test it separately even before we've created other parts of the game. Let's first know what is the node structure in Godot. Nodes are like building blocks. Every scene is made out of nodes and stuck like a tree. Each node has a specific job, moving, drawing, playing sound, etc. This is the example. This whole thing is the whole scene, while every single one of these parts are the nodes. It's important to know this concept first because parent node controls or affects its children, and child nodes depend on their parent. It moves and behaves like it, depending on the parent's action. So how is this useful? When you think of like the other games, there will be like maybe a site or maybe a line of some sort to see where the player is navigating. Like as a quick example, when you're playing FPS, right? We have like some sort of target, and the target has like some sort of distance where you want to put it. So as an example, we have, let's say this is a target node, and we need this one to be a line of sight. If you put the sight inside this object, it will trigger normally, and it will behave depending on the target node. So depending on whatever directing it to, like for example this one or somewhere else. But for example, if like the node is somewhere here, then it will not properly run. The line of sight will be dependent on the player, not on the target node that we made. So it's important to understand that if you want to develop games in Godot, that you first try to understand and pragmatically like define what type of behavior you want to create in the first place. Because if you just try to like copy paste the codes in the GitHub, you won't be able to understand it because you have to like connect nodes. Like the order of nodes is also important, and this defines the behavior of the game, and the logic won't be functional if you don't understand it. And this also makes Godot very fast when you want to make a game, because once you understood this concept, it's very easy to replicate and add other behaviors or other nodes. Okay, now that we know the node structure, we need to choose a root node for the player object. It is a general rule that a scene's root node should reflect the object's desired function. In the upper left corner of the scene tab, click on the other nodes. This one, or Control A as a shortcut, will look for an area 2D. If you take a look at this area 2D, it has a warning. This warning tells us that the node requires a shape, and we can ignore this warning for now because we will set up the player's visual first before we add the collision shape, because it will be easier that way, so we can like map it or trace it. With this area 2D, we can detect objects that overlap or run into the player. We can customize this even more by renaming it player. Before we add any children to the player node, we want to make sure we don't accidentally move or resize them by clicking on like the other nodes, right? So we want to click on this groups the selected node with its children, cause the parents to be selected when any other node is clicked by the 2D and 3D view. This causes the parent to be selected when any child node is clicked in the 2D or 3D view. We can save this scene, Control S, and we can click on the scenes folder and save it here. Take note that in GDScript, the classes that are nodes use Pascal case, variables and functions use snake case, and constants are in all caps. Now that we have the player node, let's add sprite animation. Click on the player and use the shortcut Control A. Here we'll use animated sprite 2D. This animated sprite 2D will handle the appearance of the player and like the animation as well. There's also a warning next to this animated sprite 2D. That is because we haven't added any display frames or any visual. Let's go to the animation tab. We want to click on this empty and add new sprite frames. We can click on the sprite frames to view this window. On the left is a list of animations. We can click on the default one and change it to walk. Then we can also add another animation, up. We can find the player images in the art folder. This is on the assets that we downloaded. And we can just drag and drop. So up 1, up 2 will be placed right here. And walk 1 and walk 2 will be placed in this walk list. You can play the animation by clicking on this play button. And you can adjust the speed as you see fit. At the current moment, the player images are a bit too large for the game window, so we need to scale them down. In the animated sprite 2D, click on the inspector, transform, scale. Instead of 1, we'll make it 0.5. Finally, we add a collision shape 2D as a child of the player. Click on the player, Control A, and collision shape. Then we can click on the empty, and all these lists are dependent on the type of layer shape. This kind of look like a circle, but we want to make it more look like a capsule because of the tentacles. Oh, actually I made a mistake here, so let's just drag this to the very bottom so it shows more at the most recent. And I'll try to adjust this. This point right here adjusts its width, while the other point adjusts the height. Do it like this. And we can also pause the animation if it's distracting you. Also, you can click the middle mouse to navigate it. And you can zoom in using your scroll wheel. And yeah, similar to Blender. When you're finished, your player scene should look like this. Again, if your collision shape is not on top, you can just drag and drop it because mine first looked like this, now it should look like this. Once this done, the warning on the Area 2D node will disappear as it now has the shape assigned and can interact with other objects. Make sure that we save the scene. If you take a look at this in the upper left tab beside the name of it, the player, we have this asterisk, and this means that it is unsaved. So we will click on Control S to save it. Save the scene. Congratulations on finishing the second section, creating the player scene. Now let's proceed to the next section, coding the player. And this part will add the player movement animation and set it up to the collisions. First of all, we need to add some functionality that we can get from a built-in node. So we'll add a script. Click on the player, and on this icon, click on attach script, and I'll change the location to the scripts folder. We'll click on create. We'll start off by declaring a number of variables our object will need. So you can just go to the document and just copy paste it. Using this export key allows the first variable speed to set its value in the inspector. This can be handy for values that you want to be able to adjust, just like the node's built-in properties. But the speed is not built in. This is essentially you're saying, let me add another trait for this inspector. Maybe you want to add another one for health. Maybe something like that, and health will pop up. Essentially, you can use this one just like how would you use all these traits here. Your player GD script should already have this ready function as well as the process function. This is called at the very start, and while this is called at every frame or every process. At some point you guys are wondering maybe what's the difference later, like the process and like the process physics. Like later you'll see this one in other scripts. Process delta and process physics process. This one runs every frame as fast as your computer can. It is for animations, camera movement, and UI effects. It is also frame dependent. It happens as many times per second as the FPS. So this one is FPS dependent. And physics process runs at a fixed time, like 60 times per second. Best for physics stuff, movement, etc. Frame independent, always consistent no matter if the game lags. As you can say, this one is very good for visuals, and while the physics process is good for movement or collisions or other logics. In this ready function, we'll add the screen size and to get the viewport rect size. We're essentially getting the default size of the screen that we defined earlier here in the project. So the 480 by 720. In the physics process, we can define what player node will do. Since it's called in every frame, we'll use it to update elements in our game, such as the input, the move in the given direction, and play the appropriate animation. First, we need to check for input, right? Like, is the player pressing a key? How do we define that? We can go to the project settings, click on input map, and here we can add a new action. We'll name this one move right. We can click on this add action and click on the right arrow. We can also add letter D for WACD controls, and we can add the other controls as well. This is what it should look like. In the docs, it says right here that we can detect the key whether it is pressed using the input is action press, which means if it's true, when press, if else is false. So we can just copy paste here, and I'll explain what's going on. I'll use it right here. Okay, let me explain what's going on here. If we try to play this one, like select the current screen, let's try to play it first to demonstrate it. We can see that the vector of 0 starts at the very top left corner, right? Now, if we define this as an axis, the position of the vector to 0 is in the planes instead of like in math, if we're talking about it. Instead of it being right here, the location of a sprite is currently right here. So let's say our sprite looks like this, right? So this is our sprite. Since our sprite is right here, the move right direction works normally, like you would expect. So we go here to add like the +1 to move right, and then -1 if you want to move left. But if you want to move down, we have to add more. And essentially to move up, we have to minus, and it is reverse. So in order to go down, to move down, we essentially have to add more y in the y-axis. So it's like kind of reverse. Something like this. I hope this is clear. So Godot coordinate system, origin of 0, 0, top left corner. Moving down is velocity y plus y, positive y, while moving up is negative y. So I hope you understand that part. Let's proceed. Then if the velocity length is greater than 0, velocity is normalized to speed, and then it will play the sprite. That means that the player is moving, so we'll play the animation, else it will just stop it. This dollar sign is essentially just a short version of like get node. So essentially we can just like, this one is essentially just like drag and drop, like that one, or like this, just drop it. And essentially if you want to be like super safety with it, you can define a variable by click on this one and clicking on control and using this animated sprite 2D as the variable. And yeah, that's like, it works the same way. But now that we have a movement direction, we can update the player's position. We can use the clamp to prevent it from leaving the screen, then clamping it value, meaning we're restricting it to a given range. Let's try again here. So earlier we defined the screen size, and the screen size is now essentially the viewport rect size, which is 720 and 480. That means it is clamped to the specific position. The data parameter in process refers to like the frame length. Like for example, if you take a look at this one, if you're running on 60 FPS, it should look like this one. But maybe if you're running on 30 FPS, maybe it should look like this. And we can use this some sort to like increment or something to like in terms of movement, etc. It's just a very useful process number that we can use as a measurement since it runs on every frame. Now that the player can move, we need to change like the animation that will play like based on this direction. At the current moment, it will not change, right? The animation should be flipped horizontally using the flip H property for left movement, and also the up animation, which should be flipped vertically with flip V for downward movement. We'll place this code, just click on copy and paste here. And if you're having this problem, you can just select this text, click on tab, select this text, click on tab. But essentially, velocity is not equal to 0, meaning we are not going on the x-axis. That means if the velocity x is not equal to 0, that means we are moving towards the x-axis. Will not flip vertically, I mean. And then animated sprite flip h is equals to true. Yeah, this one essentially like is velocity of x greater than 0. So this is just a boolean if you're confused. So this is true now, and then this one, this will be true as well to check it if it's flipping or not. Here in the animation list, make sure that if it's lowercase, it's lowercase, and if it's uppercase, it's uppercase, because if it's not, it will not work. So you can test it right now. For me, it's working. I'm using WASD. It works just fine. But for example, if you change this one to, like for example, like uppercase U, enter, and now it kind of like disappears whenever I go to the x-axis. Let's edit that back. So make sure that's small u. When you're sure that the movement is working, just like we saw earlier, we need to add this line that hides it. So hide here. Essentially, at the start of the game, the player will be hidden since we'll just show a HUD. Then for the next part, we need to prepare for collision. We want the player to detect when it's hit by an enemy, but we haven't made any enemies yet. But that's okay, because we're gonna use Godot signal function to make it work. We're gonna add a signal hit at the very top script of this player node. This like defines a custom signal called hit that we will have our player emit, like kind of send out when it collides with the enemy. So take a look at this one here in the node. We should have the node, the hit property. Yeah, this one on the player, and this will serve us like a signal. We can identify if we got hit by the enemy. Go to the inspector tab, and then node of the player node. Since our enemies are going to be a rigid body 2D node, we want the body entered 2D scene. The signal will be emitted when the body contacts the player. We can click on this one, so body entered, and we won't change anything here. Click on connect, and we should have it right here. To make sure that it is connected, you have this green type of door arrow next to it. So that's when you know it's actually connected. We'll add this code from the documentation. Essentially, after we are hit by the enemy, we'll be hidden since the game is over, and then the hit will emit, and we can decide whatever we want to do there later on. Collision shape set to defer disabled, meaning the collision will be disabled. We deferred it because there can't be like change of physics properties on a physics callback. We have to delay it. And lastly, we will add this function to call when we reset the player. Take note of this one. We'll connect the new game function here at the start. Congratulations on finishing the third section, coding the player. Now let's proceed to the next section, creating the enemy. It's time to make the enemies our player will have to dodge. Their behavior will not be very complex. Mobs will spawn randomly at the edges of the screen. Then choose a random location and move in a straight line. We'll first create a mob scene. So we'll save this player scene. Click on the plus icon, and for this one, we'll be using a rigid body. So let's follow the setup right here. Rigid body, 2D, child of animated sprite 2D, and the child of collision shape 2D, and the child of visible on-screen notifier 2D. Let's fix the order. Make sure that all of these are the children of rigid body 2D. Let's not forget the set this one as the group selected so they can be accidentally modified. Let's rename this to mob, and let's go to the inspector and set its gravity scale to 0. This will prevent the mob from falling downwards. In addition, Under the collision shape 2D, let's navigate the collision object 2D and click on this collision dropdown and uncheck the one inside the moss property. This will ensure that the mobs do not collide with each other. In Godot, layers and moss are used primarily for collision and detection and visibility control. They will help you manage how objects interact with each other. This is a quick breakdown. We have a collision layer right here. This is the object's identity, like a category it belongs to. So we can have different category it belongs to, and collision mass, what object checks with collision with. It's the layers this object want to detect. It basically just makes sure that it differentiates from the two. Like for example, if we have different categories or maybe different attacks, maybe you have the bullet right here. This is the bullet. We don't want it to interact with maybe the players or the player itself. We want it to interact with only the bad guys, right? So we wanted to interact with the enemies at that moment. So that collision mask and the collision player will enable us to have the specific properties to go past the player and only detects and collide with the enemies. So I hope that's clear. Navigate to animated sprite 2D, animation dropdown, empty, click on animated new animate sprite scene, click on animated new sprite scene. Let's make fly, swim, and walk. Then we'll drag and drop the specific one that we need. For enemy walking one will be right here. Then enemy swimming right here. Fly right here. Then change this to 3 FPS. 3 FPS. 3 FPS. And if you want to adjust it again, just play it. This is fine. Scale 0.75. Now let's make the enemy script. In the mob node, let's add another script, which is mob.gd. Let's add it to our scripts folder. Click on enter. Now in here, okay, so for the first one, we're defining a mob type. First of all, there's an array of the animated sprite frame that get animation names. What this means is for every sprite frame, we're getting all of its animation name. This is like the fly, the swim earlier that we added. So let's try to paste it right here. The output of this first line will be something like this. So fly, swim, and walk. And from this, we're gonna pick a random mob type, play it. So we're only picking a random one, but we're not actually playing it yet. To play it, we need to add another code. We'll add this, which is animated sprite 2d.play, so that after picking something random, it will play the animation. The last piece is to make the mobs delete themselves when they leave the screen. We'll connect the screen exited signal from visible on-screen notifier node to the mob node. In the mob node, we'll navigate to visible on-screen notifier and click on screen exited. Then we want to connect it to mob, and there we have it. Make sure that you have this green. Again, if you're just copy pasting code, it won't work. You have to manually connect it. Then we'll add a queue free so that when it exits the screen, it will remove itself. This completes our mob scene. Let's save it first in here in the scenes. And congratulations on finishing the 4th section, creating the enemy. Welcome to the 5th section, the main game scene. Now it's time to bring everything with it together into a playable game. Let's create a new scene, and this time we'll just add a node. Node, create. The reason why we're using node instead of node 2D is because the node will be a container for handling game logic. It does not require 2D functionality itself. So this node 2D will both work for 3D games and 2D games. We'll click on the instance. We'll rename this to main. To add the scene, we'll use this in that instantiate child's scene right here, the chain one, and we'll select the player scene. So click on this player scene. we're essentially making the player scene a child scene. So just like with others, we can reuse scenes like the mobs, the players, and that what makes Godot very good. Now let's add the following nodes as children of main and name them as shown. So I'll do just that. Control A, timer, rename this to mob timer. Make sure it's a child of main. Score timer, then start timer. Start. And then in the mob timer, we'll set the wait time for each node respectively. The mob timer to be 0.5, half a second, score timer 1 second, start timer to be 2 seconds. In addition, let's set the one-shot property of start timer to be true. Okay, let's also add a mark 2D, I forgot. Marker 2D. And let's rename this to start position. And we'll set the position to be 240 by 450. Let's save this first to the scene. Now it's time to spawn mobs. The main node will be spawning new mobs and we want them to appear at a random location at the edge of the screen. In the main, we'll add another child, which is path2d, and name it mob path. When we select path2d, we will see these new buttons. We'll select the middle one, which is you can just hover it, and we'll select on add points. So here 1, then 2, then 3 and 4, then 5 is to close it. So 1, 2, 3, 4, and 5 to close it. Close curve. Now that the path is defined, add the path follow to D node as a child of mob path. So as the child of mob path, and here we'll add path follow to D. Path follow to D. We'll rename this to mob spawn location. This node will automatically rotate and follow the path as it moves, so we can use it as a select random position and direction in the path. Now in the main script, we'll add a script for the main node. Here, scripts, create. We'll add this code again to export the mob scene into a packed scene. And just like before, same with the speed. This time we're defining a packed scene similar to what they call this, like in the like for example, think of it as like this one, the animated sprite 2D. They have some sort of like this packed media over here, right? We're basically doing something similar, but we're defining it ourselves. So we can insert the scene here instead, very similar to it, and it save it as like a scene that we can reuse and instantiate later on. Now if you click on the main scene, we can see this mob scene right here. We can assign the property. Again, let's try to load the mob scene from this mob packed scene. We'll click this and make sure that it's stored right here. What we want to do is after we went to the player node, we'll click on hit. We'll rename this to game over and we'll click on connect. Now it's connected from the player to the main script. Then we'll just add the function new game. So we'll just copy paste this one. Remember, make sure the game over is connected or else it won't work. This one should show if it's successful in your part. The next part, now let's try to connect each timeout function from this to this. So we'll click on timeout, we'll click on main, we'll not modify it. Make sure that there's a signal, timeout, here, again, here, main. Now we should have all of these, just like this one. Now here, we'll just copy paste the code. The on-score timer timeout, meaning after a second has passed, this will trigger. So this will be our score variable. Since we set the score timer to 1 second only, like let's say for after 1 second, then boom, this will happen. And then for this one, start timers on 2 seconds. So after 2 seconds, this will happen. Mob timer start and score timer start. So after 2 seconds, both of these timer will start. In here, it says in mob timer timeout, we'll create a mob instance, pick a random starting location on the path to D, set mob in motion, path followed node will automatically follow, select node mob direction as its position. When the spawn random will pick a random value between 150 and 250 for how fast each mob will go. I'll explain it on more detail after we copy paste it here in the mob timer. On the first part, we're creating a new instance of the mob scene. This is the pack scene that is available in main. This one, so the pack scene. And then for the mob location, we're essentially just importing this one as well, same as earlier. And then for the mob location progress ratio, it will be a random float. I'll explain later. Then we'll set the mob's position to the random location. What is this? What's going on here? The simple explanation here is like it's perpendicular, right? They say right here is a perpendicular path to direction. So I'll try to make this much simpler. In here, let's say we have the scene. This is the whole game scene. What we're trying to do is there's supposed to be a random location right here. This is the first random location. This is the side of the map, like the edge. And now, what they're saying here, direction perpendicular to the path, meaning it's just a random angle. So let's say let's draw like maybe in here the angle is like this one. So this is the whole angle that's available. We'll pick a random location here. For example, maybe I don't know, maybe this. So from this part, the mob will travel from here, and this is the perpendicular. It will then go to a straight line where it will go until it exits the screen. That's the radian working right here. So again, just a very simple explanation. If there's a mob on this path, and it will just pick a random angle or radian right here. So let's say it picked something like this. So it will go here, is the radian, and then it will go in this direction straight until it's done. Okay, so it's just picking a random angle basically. Next up, the mob rotation. It will adjust depending on what rotation that is. So make sure that it's facing the correct way. Then we'll choose a random velocity, which is the speed of the mob. Then we'll spawn the mob by adding it to the main scene. Make sure that this one is the very last, because we need to know why is it there in the first place. What will happen if you put this at the first part? In some cases, it will like just stay there and then wait for some time, and then before it calculates it. So it's important to add it at the very last so it stays invisible and not added to the scene already. We can test the scene by adding a new game in the ready function. In the ready, let's make this new game, enter. Let's also assign main as our main scene. We can click on the play right here. If it's not playing like it's like this, you can just click on run a specific scene and click on the main scene, and we should have this. Now we have players randomly spawning. Okay, we don't have that logic. We don't have that logic yet because I forgot to add a collision shape 2D. I'll add a new collision shape, new capsule, then rotate it. Position should be about like 90. Then I'll adjust the shape according to the mob size. Then let's try to play again. Click on the main scene. Let's try to test it. And now the player disappears and everything disappears. That's great. And we should also set the main as our main scene. So currently it's kind of like not doing that. So let's go to the script scenes right here in the file system. Let's click on main scene and let's set as main scene. There we go. When you're sure and you've tested everything that it is working, we'll remove the new game from the ready function and replace it with pass. Let's go with the script and just go back to pass. And that's it. Congratulations on finishing your 5th section, the main game scene. Now let's proceed to heads up display. Now let's proceed to the section heads up display. The final piece missing in our game is a user interface. This will display the messages like start, game over, the score, and the restart button. Let's create a new scene and then click on other nodes. And we'll add a canvas layer. We'll name this HUD, which is a short term for the heads-up display. This canvas layer is an informational display that appears as an overlay on top of the game view, so it will always remain on top. This lets us draw our UI elements on a layer above the rest of the game so that the information it displays isn't covered up by any game elements like the player or mobs. To create the control elements, we'll use labels and buttons. This is what we'll be adding as the children of HUD. Label and score label, then message, then button, then timer, start, message timer. We'll click on the score label and add a number inside it. The default font for the control node is small and doesn't scale really well, so we'll add a font file that's included in the fonts assets. So let's go to theme overrides, just scroll down, click on theme overrides, fonts, click on this tab, click on load, and go to fonts, click on this Selenium regular, click on open, and we should have it now. The font size is still too small, so we need to increase it to 64. Under the font sizes, we'll make this 64. We'll repeat these changes in the message and start button nodes. Go to message, theme overrides, fonts, load, fonts, Selenium regular, font size 64, start button, theme overrides, font size 64. Then fonts will be this one. Control nodes have a position and size, but they also have anchors. This is basically a way to like a preset, so that way there's a uniform way of placing the text on the screen. We can click on score label, make it center top, and go to inspector, change the horizontal and alignment to center as well. So center and center. This is what it should look like. For the message, we'll go to the anchor. Before that, let's add a message first. Message. Then for the anchor, it will be center. Then we'll click to the word. We'll set the auto wrap mode to true. To word, I mean. Now under control tab, we'll modify the layout and the transform here to be size X 480. Yeah, but before that, let's change it to a vertical center as well, and vertical to the center. There we go. Yeah, just click on center again. Now for the start button, we'll go to control, layout, transform, size X to 200, and the Y to be 100. Let's also change the text to be start, and then we'll choose the anchor preset of center bottom and position the Y to like 580, because as right now it's like very maximum at the very bottom. We'll change the position Y to 580, this one. 580. On the message timer, we'll set the wait time to 2 seconds and set the one shot property to on. Now we'll add a script to the HUD. So we'll create a new script here. Gonna make sure that it's in the right folder. Scripts. We'll add a signal that starts the game. Now we also want to display a message temporarily, such as get ready, so we can add the following code. We'll add a new function here to add it. The code below will show the game over for 2 seconds and then return it to the screen. Yeah, this is basically the show message function from earlier, which is this one. Then it awaits the timer, timeout. It waits for this to finish, which is 2 seconds. And then the message text will be converted to dodge the creeps. Then it will show it. Get read timer. This is just an artificial timer to wait. It's like a 1 second delay. And then it will show the button. function. At the moment, it's not connected, but later we'll connect it. To update the score, we'll add this code as well. We'll connect press signal of the start and then timeout signal of message timer. So for the start button first, let's go to start button, click on node, pressed, connect to the HUD. We should have this message timer, timeout, click on the HUD, and we'll add both of this code. What's happening here on the start button, when I press on the start button, it will hide it and it will start the game. So it emits that, oh, the game is starting now. And then on message timer, the message will be hidden. This is just a signal for the message to hide after the message timer is done. Now we need to connect the HUD scene to main. Let's first save this, Control S, and make it a HUD scene here. Let's go to the main node, and we need to instance the HUD scene domain like we did to the player. Now it should look like this. Click on this chain, press on HUD, and make sure it's the child of main. In the node tab, we'll connect the HUD start game signal to the new game function. We'll go to HUD, and you can see a start game function right here. We'll go to the HUD node and go to the node section right here and click on the start game to connect it, and we'll rename this to new game. Remember the script in the HUD that we'll be connecting? We'll connect the new game function here. So now this should be a new game function. Let's click on connect, and now there should be a signal. As in before, it's just a normal function. Make sure that you type it correctly, so it should have the signal right here. You can verify it. And then in this new game, we'll add two additional code. This one here, tab. Then in game over, we'll call the corresponding HUD function. Show game over. Oh yeah, we forgot to add this one. So we need to update the score. So let's go back here in the HUD and update the score because we didn't use this function. Again, let's try to replay it. So the player can walk, and game over. And if you take a look at it, some of the mobs are still in the screen. So what we need to do is to make sure that they are as a group, so they can disappear all at once. In the mob scene, this is the mob scene. Let's go to groups, and we'll add a new one. Let's name this one mobs. Click on enter. Then we can add the following code to the main new game function. Control S, main new game. What this does is it will call the goal group function and calls the name group function on every node in the group. In this case, we're telling every mob to delete itself, so there's no leftover mob. Congratulations on finishing the section 6 heads up display. Now let's proceed to the last section, which is finishing up. This is the last section, which is finishing up. Since we have now completed all the functionalities, all just left to do is to add a color for the backgrounds and some sound effects. At the current moment, the background is colored gray. Let's go to the main node and add a color rect node. I can get the color by using this one. You don't have to install this extension. I'll just put it here so you guys can copy. So this is the color, which is 396D70. Click on enter. We also need to adjust this one. The anchor should be full rect, like that. And now it's time to add sound effects. The sound design can be like one of the most effective way to add appeal to the game experience. An asset here that we downloaded, game over that wave, and this house in the forest loop. We can add to audio stream player. Control A, click on audio stream player. Audio stream player, click on create. Let's name this one music. And we'll also add another, this one, and we'll put it in the main node. Let's name this one that sound. In the inspector tab, tap on the stream and load the specific sound. Let's go to art. For the music, it's this loop, OGG. For that sound, It's this game over.wave. Let's go to music here. To make the stream loop, we can just click on this drop down arrow and click on make unique. Make unique and click on this drop down interface and check on the loop icon. Then we can add this music stop and the music play on this specific function that we wanted to. I'll copy paste this one, go to script main, and on new game it will play, but on game over, stop the music and let that sound will play. You can add this additional stuff for it, but I feel like this is too complex for you guys, so I'll just skip this one, and it's not really like that essential. I'll play the game. I'll start it, and as you can hear, there's now an audio. At the current moment, the player seems to be missing for some reason. Let's go to 2D and see why is that happening. That is because of the order of node. That's why it's super important. Because if you take a look at here, it actually does exist here, but it's like behind a different layer. We can go to color rect and put it at the very top to fix this issue. And now this one should be on top. So before it was like this one, right? So it's covering the player. So make sure it's at the very top. This is super important or else it will be invisible. And let's play the game. And look at that. It's now okay. Just those small stuff really matters because you can be very stressed out. That's why I made this tutorial. And if you're wondering how can we adjust like the difficulty if you're having a hard time, you can just the mob timer, we can increase the wait time to be even higher or maybe lower if you want it to be much more difficult. But yeah, that's the tutorial. Now let's save everything here and let's upload it to GitHub. I'll exit this one. How can we upload it to GitHub? First of all, I want you to download Git. This will be like the version control that we'll be using. You can download using the Windows here. And while that's downloading, Git is basically a tool that helps you track changes, collaborate and others, and go back if something else goes wrong. Other people use GitHub desktop and add their GitHub there, but I found another neat way to make it like faster and using just a terminal as a code if you just want a click upload. So once you have your Git installed, you can go to GitHub and we can make a new repository. Very simple stuff. Add a new one. Our first 2D game. Now let's go to the file directory that we have. This is our file directory. Let's go to our game project folder, which is this one. If you have Git installed, you should have this option right here. I'm not sure what is like happening with Windows 11 on why they don't have this feature. But if you don't have that feature, you can just open Git GUI. So click on Git bash. So click on Git bash and you should have it right here. And like you're not sure what to do now because how do I cd into that specific file? Well, you can look for this one, right? You can find the file of it and cd to that file. So copy this, paste, enter. Now we're in the specific game file, and now that's very similar, right? And what else do I do? We need to navigate to the first 2D game. So cd first 2D game, and now you should be in that directory. If you don't have like this option right here, you can use that one. Very simple, cd to the specific folder and just cd to the specific folder again. But if you have Windows 10, you can just click on open git bash here. Look at this, it literally does the same thing. You can just click on cd on the specific spot and it works the same way. Now that we're inside this path, we want to upload everything of this contents inside this repository. That's very simple stuff. This is just a terminal. Before we git add, I mean, we need to git init to initialize, git add, git commit dash m init. It should upload all the contents of this first 2D game. And then next up, we want to add a remote origin. You can just click on this one and just click on paste. It should be all updating. We can try to refresh this one. And now we have all our contents for our first 2D game. This is only when you are uploading it to GitHub, but the game is not necessarily playable yet. There's a lot of steps tutorial because it requires you to download a lot of stuff, and since this is just a tutorial, I don't plan on like adding it yet. But if I were to make like my own game and like want to like deploy it online, I would do it. But for this case, uploading it to GitHub is fine. But if you would want to, you can search for it. And yeah, thank you for watching.